Hello everyone. Before trying this next lesson, let's start with a warm-up. Here's a function f of x equals 1 over x. What values are impossible in this function? So just to clarify, what values of x will not work? Pause the video, see what you can come up with, and then check back in. Well, maybe you noticed this. If you put 0 here, you can't do it. 1 divided by 0, if you do that in your calculator, it'll say that you're getting an error or some sort of message like that. The point is, 1 divided by 0 is undefined. So for this function, x cannot equal 0. It's impossible. Now, if you think about the function, instead of in function notation, just notation like you would be used to in grade 9 or 10, where we say y equals 1 over x. If you think about what values of y are impossible. Well, in a similar way, y cannot equal 0 because 1 divided by any number will always be some other number, not 0. When you divide by a number, you're saying how many times does that number go into your numerator? So if I have 1 divided by something, 1 divided by 2, how many times does 2 go into 1? Well, half a time, it's 1/2. 1 divided by 100, how many times does 100 go into 1? Well, 1/100th of a time. You're going to get smaller and smaller numbers, but you'll never divide 1 by anything to get an answer of 0. So x cannot equal 0, y cannot equal 0. These are what we call restrictions on the function. And that leads into today's topic, domain and range. We're going to talk about what domain and range are, and then we're going to use tables, graphs, and equations to find the domain and range for a function. So first we'll talk about what it is, then we'll talk about how to figure it out. So let's start with some terminology. Domain is the set of all x values in a function. Range is the set of all y values in a function. You can think of domain as all the possible values you can have for x, and range is all the possible values you can have for y. So regardless of what type of function you're dealing with, whether it's linear, quadratic, exponential, etc., you can always figure out what are the possible x values and what are the possible y values that can exist on your function. And when we communicate what the domain and range are, we use set notation, which if you'll recall from an earlier lesson, that's where the curly brackets are used, and you list out all the possibilities inside the curly brackets. So let's illustrate this with an example. Determine the domain and range of the following relation, and then, is it a function? So here's the relation. It's the set of all these ordered pairs. So if I want to write what the domain of this function is, I have to write it like this. I need to start with my curly brackets. Now inside the curly brackets, I have to write what the domain is. Remember, domain is all the possible values of x. So if I look at my set up here, x can be -3, 5, -2, 5, 6. So if I simplify it, take out the repeats, it's either -3, -2, 5, or 6. And the way I communicate that is by writing it like this. X is equal to -3, -2, 5, or 6. So I'll put it all together. This is how I communicate what the domain of my relation is. Likewise, I can list the range. The range is all the possible values of y that exist on this relation. So y can be 4, -6, 2, 3, or -8, and I just put that in order. Y is equal to -8, -6, 3, 4, or 7. So domain is all the possible values of x. Range is all the possible values of y. So determine the domain and range of the following relation. Done. Is it a function? Do you remember how to tell? Well, if you've forgotten, a function has only one output for every input, or only one possible value of y for every value of x. Well, if we look here, when x is 5, y is -6. And again, when x is 5, y is equal to 3. So is this a function? Well, for an input of 5, we have two different outputs. When x is 5, we have two different values of y. Because of that, this is not a function. Now, before we get going further, I want to talk about types of numbers. So you can see this confusing chart that says the real number system. We've got rational numbers, irrational numbers, integers, whole numbers, natural numbers. We've got symbols to represent each type of number, and we've got examples of each type of number. So let's build this. When you first learn how to count, you count 1, 2, 3, 4, 5, etc. Those are natural numbers. It's the way we naturally count things. They're also called counting numbers. But then you get to a point where you need a number to represent nothing, or you need a 0. So when you add 0 to the list, now we have whole numbers. So whole numbers are all of the natural numbers with 0. Then we build on top of that. Now you start thinking about numbers in terms of gains or losses. We need negative signs and positive signs. Now we're talking about integers. So integers are all of the whole numbers with negatives as well. And so now we have a new type of number. But now we can get to trickier numbers. Now you start to you need a way to represent fractions, parts of a whole, instead of just whole numbers and integers. So this is where rational numbers come in. Rational numbers are just fractions, a over b. Now, all these different types of numbers you have used before in your everyday life. You've used natural numbers, whole numbers, integers, and rational numbers or fractions. All of these numbers that you have used in your life are what we call real numbers. Now, some real numbers don't fall into these categories, like the square root of 2 or pi. These are numbers that you cannot represent as a fraction because the decimals are non-repeating and never-ending. So if you have numbers like that, they're called irrational, but they're still real numbers. You deal with them in real life. So I bring this up because there's different symbols here to represent different types of numbers. And when we're talking about domain and range, we can use these symbols in our communication of domain and range. So if x can be any natural number, we can say, we can use the symbol n in our domain statement. If x can be any real number, like a natural number, a whole number, an integer, a rational number, or even an irrational number, if x can be any of these types of numbers, we're just going to use an r as our symbol for all real numbers. Now let's keep going. I'm going to use symbols for number types. I just wanted to make sure you knew what the symbols meant. Okay, so let's do another example. Sketch a graph of the function. Then state the domain and range. F of x equals x. Now, you will have this, if you followed along with the last lesson, you'll have this on your help sheet, your summary notes. F of x equals x. That's a linear function, and it's going to look like that. Now, we want to find the domain and the range. Remember, domain is all of the possible values of x. So as we look at this function, which is supposed to be a straight line, we can find different values of x and what the corresponding value of y is. So x can be 0 because we have a corresponding value of y on the graph. X can be 1 because we have another value of y that corresponds to a value of x. X can be 2. X can be any of those integer values. It can even be negative because regardless of where we go on the x-axis, we can find a corresponding value of y. So x can be 0, it can be positive, it can be negative, it can be whole numbers, it can be integers, it can be fractions, it can even be irrational numbers like pi. If we found pi on the number line here, we could find a corresponding value of y. X can be any real number. So how do we write that? Well, we need curly brackets because we're using set notation. And inside the curly brackets, we're going to write this. X is an element of the real numbers. That's what that means. This is not the letter E. It's kind of curved here, supposed to be. It's a symbol that means an element of. It just means X is part of the real numbers. So this script R, that's why I put 2 lines here, that's the symbol for the real numbers. X is an element of the real numbers. That just means X can be any number. Doesn't matter what type. It's any real number. Now let's think about the range. The range is all the possible values of y. Look at the y-axis. If you go anywhere on the y-axis, can you then go out to the function and find a corresponding value of x? Well, yes, you can. There's no restrictions on what y can be. Y can be anything. So we're going to write the range in a similar way to what we did for the domain, except we're talking about what y can be, not x this time. So y is an element of the real numbers. Y can be any real number. There's no limits on what it can and cannot be. It can be anything. Now I've changed functions. F of x equals x squared this time. This is the function shape. It's a parabola. Its vertex is at the origin, 0, 0. So we're going to talk about domain and range again. I'm going to use D for domain, R for range, just to shorten things up. When I talk about the domain of this function, we're going to use set notation. So we use the curly brackets, and I got to think about what x can be. Well, x can be any real number. Are there any limits on that? Well, x can be 0 because I have a corresponding value of y when x is 0. X can be positive. Any positive number for x gets me a corresponding value of y, so it works. And x can be any negative number because no matter where I go on the negative side of the x-axis, I can find a corresponding y value. Keep in mind, because of these arrows are here, it means that the function keeps going. So the function keeps getting wider and wider and wider. So no matter what value of x, I'll just have to go up higher and higher to find the value of y. But there's no restrictions on what x can be. Now, let's talk about the range. We'll use our curly brackets for set notation. Y can be any real number. However, not every real number. It can be any of the real numbers that are up here, but on this function, y is never down here. Y is never a negative value. It's either 0 or more than 0. So the way we write that is like this. Put a vertical bar here. This means we're introducing what we call restrictions. Y must be greater than or equal to 0 in this case. The reason I say that is because the lowest possible value of y, just go on the y-axis, find the lowest possible value, 0. Every other y value on this function is more than 0, greater than 0. So we use the greater than or equal to symbol here. Okay, so when we write domain and range, we can say it's any real number, it's an element of the real numbers, And then we introduce the restrictions on that. So exceptions to that. Y is any real number except for it has to be greater than or equal to 0. That's what this means. So this is more of a communication piece that you have to get used to, but with practice you can get a handle on it. Now this was the square root function. I think you should try this now on your own. So pause the video and see what you come up with for the domain and the range. If you look at the values of x, they're all either 0 or more than 0. So there's your restriction. X is greater than or equal to 0. And for the range, look at your y values. The lowest is 0 and anything bigger. Never negative. So y is greater than or equal to 0 as well. And don't forget this part. You still have to state that x can be any real number, y can be any real number with these restrictions. So make sure you have both parts with a vertical line separating them. And then you've got the curly brackets around your set of numbers. And if you have all those parts, then you've got great communication for stating your domain and range. Now this was the reciprocal function, 1 over x, and this is what it looked like. And you'll have this from the previous lesson. And I'd like you to try the same thing. See if you can write out the domain and the range for this function. Don't forget the asymptotes. Y equals 0, x equals 0. The function never touches those lines, so x cannot equal 0. Y cannot equal 0. X can be positive, x can be negative, but x can never equal 0. Same with y. Y can be positive, y can be negative, but it will never equal 0. So that's where those restrictions are coming from. And just as a side note, we were looking at this in the warm-up today, and we looked at what values of x and y are impossible. So that also is explained by this graph. We get asymptotes in those spots, so x cannot equal 0, y cannot equal 0. And again, just remember you're doing everything you need to do for proper communication. You've got the curly brackets, you've got the first part, x is an element of the real numbers, the vertical line, and the restrictions. And if you've got all those parts, you've got good communication. Here's one more graph that we're going to look at. See if you can pause the video and come up with the domain and range on your own. Then check back in to see how you did. So pause the video and try this one. Well, here you are. I hope you didn't get tricked and added any restrictions on the domain, because x can be any real number. It can be negative, it can be positive, it can be 0. There's no restrictions on x. So this is how you write the domain. Y has a restriction though. Y must be greater than or equal to 0. And my last example in this lesson deals with just the equation of the function and not the graph, but our goal is the same, is to find the domain and the range. So for this to work, you have to be aware of a couple of things. First off, here we have a square root, so you need to know that you can't take the square root of a negative number. That's the key to this one. Also, for the next function, you cannot divide by 0. That's the key to this function. So if you keep those two ideas in your mind, that you can't take the square root of a negative number and you can't divide by 0, then you can use that to figure out what the domain and range would have to be for these functions. So why don't you pause the video and see if you can actually figure this out, and then check back in to see how you did. So let's talk about this first one. F of x is equal to the square root of x plus 2, and then subtract 1 from that. Now, remember, you can't take the square root of a negative number. So what values of x would make this negative in here? Well, if x is negative 2, this would be 0. That's okay. The square root of 0 is 0. So x can equal negative 2. But can x be less than that? Can it be negative 3? Well, no, because negative 3 plus 2 is negative 1, and I can't take the square root of negative 1, so that won't work. X must be negative 2 or greater than that to make this work. So x must be greater than or equal to negative 2. All right, now, what's the lowest this could go? 0. If this whole thing was equal to 0, subtract 1, your y value will be negative 1. That's the lowest it can be. So y has to be anything greater than or equal to negative 1. That's how you got to think through this. What are the values that x can't be? What would break this function or make it function improperly? That's how you decide what the restrictions on x are. And then you can use your other knowledge. What is the lowest that y could be, or what is the highest it could be, or anything like that to figure out what the restrictions on y are. Likewise, for this next function, this is a reciprocal function, except it's not 1 over x, it's 1 over x minus 4. You can't divide by 0, and that was the key to this one. So if that's the key, here's where that gets you. If you were to have x equal to 4, 4 minus 4 is 0. You would then be trying to divide by 0, which you can't do, which means x cannot equal 4. That's the only restriction on x. Also, there's no way to get a y value of 0 because 1 divided by anything cannot equal 0. So that's how I came up with the restriction on the range. Now, domain and range from an equation is a little trickier than from a graph. So I understand if you're having some concerns about where these are coming from, but that's always something that I can help you with. You just have to ask. Now it's time for a challenge problem. This requires you to remember quadratic functions from grade 10. If you forget that stuff, that's okay for now. We will focus on quadratic functions later in the course. This is more of just to jog your memory and get you thinking. So if you remember how to do this, great. Try the question. If not, you can just kind of do your best, and then I will take this one up. So a ball is kicked in the air. Can you picture that? Someone kicked a ball, it went up. What's going to happen? It's going to come back down. So already you can kind of imagine the shape of the graph. Ball goes up, ball comes back down. The height in meters at time t seconds is modeled by this equation h of t is equal to negative 5 times t minus 4 squared plus 80. H of t, height, as a function of time. So if you know what the time is, you can calculate the height. Determine the domain and range. Now, if you don't remember how to graph a quadratic function from the vertex form, that's okay for right now. We'll get there. Just use a graphing calculator to help you with this question, and you can use that to help you find the domain and range. Now, I want to caution you. The domain and range for this problem, you have to think about it a little bit differently because this is a practical example. We have a ball being kicked. We have to put practical restrictions on the function. So think about the values of time and height that actually make sense in the real world application. That's where we're going to get the restrictions for our domain and range. Okay, so if you're up for the challenge, pause the video, get a graph, figure out what the domain and range would be for this particular application. Okay, so pause the video and see how you do. If you were to graph this using Desmos, for example, you'll get a graph that looks kind of like this. Now, I've just highlighted a couple key points, the vertex and this point right here. The reason I'm not talking about these other points is because they're not really important to what I'm about to say. However, let's talk about domain and range. We're not going to use the symbols x and y because we're using t and h instead, time and height. And I mentioned this earlier, because this is a practical example, we have to put practical restrictions on the domain and range. So, let's talk about the domain. That's time. Well, time can be any number, but what actually makes sense? The function actually only makes sense here to here. So anything outside of that doesn't really make sense, because over here, time is negative. That's before the ball was kicked. That doesn't make sense. And if you go further on the time axis over this way, the height is going to be negative, which doesn't make sense. The ball's not going to go down into the earth and keep going. That doesn't make sense. Only where I've highlighted it does the graph actually make sense in the real world. So, what are the limits? What are the restrictions on time? Well, it has to start here when time is 0 and end here when time is 8 seconds. So from 0 to 8 seconds. Now, how do I write that? Well, the domain is time. Time is an element of any real number. Now, the lowest it can be is 0. The highest it can be is 8. And t can be any number in between. It's greater than or equal to 0. It's less than or equal to 8. And that's how you can write the domain for this function. Use your greater than or equals to symbols. Put t in the middle, your minimum and your maximum on either side of that. Remember, the greater than or equal sign symbols, they always open up towards the bigger one. So if 8 is the maximum and 0 is the minimum, make sure all of your greater than symbols open towards the 8. Now, maybe this makes sense to you now, and you want to pause the video again and try to figure out what the range of this function is. That's fine. You can do that now. And that's what it would be. Height can be any real number. In between 0, that's the lowest height, and 80, that's the maximum height of this ball. So 0 is less than or equal to the height, which is less than or equal to 80. 80 is the maximum, 0 is the minimum. All the signs open towards the 80. Okay, so this one was a little bit trickier. Once you have the graph, you just have to put practical restrictions on this practical example, and you can find the domain and range for the function. And now it's time to practice. So just remember the key point that domain is all the possible x values, range is all the possible y values. There are certain communication aspects to how you properly communicate domain and range. Curly brackets, use the symbols, it's an element of the real numbers, and then make sure you're using the correct symbols for your restrictions. Greater than, less than, not equal to, those types of symbols. Okay, so do your best, and if you need help, reach out and I'll be glad to help you.